Is everybody in? Oh, okay. Hey, I just want to welcome everybody here tonight. We've got a local guy here, Dr. Dave Flanigan. He's going to be presenting, what is it there? Exploring the test and evaluation space using model-based conceptual design. Dave's a member of the principal professional staff here at Johns Hopkins University and is vice chair of the Johns Hopkins University Systems Engineering Program. So, Dave, if you're ready.
Thank you. Okay, so thanks for coming out here, and good to see some familiar faces in the audience. So this is a presentation that we gave last year at the International Symposium in Orlando. So myself and Kevin Robinson, he lives in Australia, and he's with the Scholl Group, and they do systems engineering out in Adelaide in Southern Australia. So if you went to the IS back in 2017 in Adelaide, these guys did a great job hosting us there. So we had worked together a little bit, and then we're going to talk a little bit about what we did last year in 2019 and the presentation. And then also a little bit of what we're going to do in 2020. So and actually just this Monday we just got told that we were accepted for presentation and the 2020 IS. So it's really good to see that. So it's going to be sort of a look at the past and also a preview for the future there. Okay, so how did we get here? How do we get to this today here? And it's photo credit to Paul Martin here, even though he doesn't realize this. So this is back. So last year, if some of you were here, this is in Orlando. So this is the big plenary room, where everyone does their keynotes and a lot of speeches and all that. And traditionally, after like about the last day or the day before, it's tradition to have your chapter to come up, to be in around the stage and take pictures, and put them on the website and all that good stuff. So everyone remembers that. So I was talking to Paul earlier in the conference here, and so he takes this picture, and then afterwards he sends this out to to everyone, trying to figure out who's who, where everyone is. And then you get, not sure who that is. So I was like, hey, here's the kind of thing of, it's me. So and so yes, that is me in the background. But and that kind of gave a good intro to be able to say, hey, yes, we'll come present what I had here at this. So that's sort of the genesis of this thing. Okay, so what we're going to do here, we're going to talk a little bit about model-based conceptual development. So this is something that Scholl and they had actually done a bit, and there's some work in the literature that you can also see, but really what they're doing here, it's model-based conceptual design. Okay, so it's a little different than model-based systems engineering, but you can see, and as I'm going to go through it a little bit with the background, you can see what the similarities are. And so that was good to see, and obviously, like any other good systems engineering, you'd like to be able to have that and promote that better understanding. If I can actually describe this and give it to you in some sort of fashion, then hopefully everyone can have a better understanding for that. So that was good, but as I was talking with Kevin and his folks and looking at the literature, it was good at the very beginning, but this concept really could have also, been extended to, not only after you start with the conceptual design where you start from nothing, but how about afterwards, and especially with our test and evaluation folks here. And that was just one example of here's an application to that. So that's what we really want to try to do is take that, extend that process, and hopefully what we hopefully will get from this is that if you do this, you apply it to a different domain, and now all your decision makers, your stakeholders, everyone involved can get equal insights to the T&E considerations, as well as being pretty faithful to the MBCD techniques here. Okay, so in this last year, in 2019, we did a sort of a 5-step sort of approach, and we'll kind of go through each one of these as, you know, how relevant is it, give you a little bit of the background of what that really is, and then how we then extend that into the test and evaluation world. Okay, then we can also start to show the different linkages within that test domain. You know, unlike, you know, or pretty similar to the other model-based systems engineering and other concepts here. It's all about the linkage. It's all about, you know, what you're doing, and then how you're going to evaluate, you know, that concept, that model, and to be able to do that. And finally, to be able to have that insight gained when you change one item in one area, and how that ripples through, that changes ripple through to the other domains. So that's kind of where we're headed for the 2019 area here. So by way of background for MBCD, again, it's used a lot to be able to help build this, to be able to structure what you have in there with both the problem and some of the solution sets. And as you start to link all of those together, then you'd like to be able to do a couple things. So one, it's to be able to also help the decision makers as you build this. You know, are you addressing the right problem? Are you hitting what you need to do? Are you linking to your strategies? And then also, as the developers who actually have to do all the work, you know, are you actually driving to the right solution set? So obviously you can start to see if you don't have any good linkage, good communication, good processes, then, you know, one direction could go one way and your developers are going the other way, and soon you got not a good system to do. So this is really the broad view of what MBCD is, and you know, it's fairly self-explanatory with similar to a systems engineering approach. So it starts from left to right, and just kind of briefly, it begins with their strategy. And again, as you can imagine, it's got some of your different objectives and your guidance and what you want to do for that. And then as you roll into the operational section, it's what you're doing, how you're doing it, how you're measuring it, and again, how to be able to help satisfy that strategy. Now you start to narrow down into a little bit more detail, and now you get into the systems portion. It's actually kind of broken out into both hardware and software. But again, as you start to get more into the details, the components, the functions, the metrics, and again, how your hardware and software executes your functions, which hopefully then describes and satisfies your strategy. So again, nothing unlike that you already have seen, you know, with the systems engineering process. So this is their points, and again, each of the different blocks there with the elements, then you're able to use this and help hopefully build insight there. Okay. One more thing. So as some of you know, maybe possibly not all of you. So why would you use a model for this? This sounds pretty self-explanatory, right? So I have strategy, I can tell you what you're doing. As long as you're going along and following my, you know, guidance, we should be all right. Great. But what happens when, you know, one of these blocks here changes? You know, and you know, how do you pass that information? The old school way, if you just did, you know, paper, bounds of paper, reports, well, you can do that, and you can pass my report to someone else, and they can take it, and someone else. Well, what happens when you change it? Well, manually, then you have to scroll through your report and make the changes and update it. And you're probably not going to get them all right, and then you're going to hand it to someone else, and they may not get it right. So obviously, with the model here, if you have it all linked and integrated, you make one change, that automatically will start to ripple through and make the changes, and so everyone's got the same sort of update. So that's one way, in one, you know, sort of advantage of using a model versus a paper-based sort of approach there. Okay. So hopefully for some of you, this is old news for that. Okay, so now that we gave you sort of the overview of what is MBCD, now let's try to extend it to this to the T&E approach here. And really, what we're going to do is try to address the domain, use that methodology that we just looked at, and then try to now apply it to the test sort of domain, and what kind of activities are you doing in the test? How many tests, or what are you doing with the tracing your test to your requirements? And then also, what are you doing in terms of your components that are actually on the test range, for there? And so there are plenty of test domain areas here that you can look at. We just kind of looked at a few of them in terms of our aspects of what goes into a test area, and this is as we're starting to build our test domain here. Kind of so starting from the kind of the 9 o'clock, the leftmost position here, as you're doing what we call the test article, that's really your system under test. What are you gonna test, and it's got to operate under some sort of test constraints. Well, it also will operate within a test event that runs, what you're gonna do, as well as go after some test targets, that may be different than your testing, operating in a range, and then eventually, as you start to do your work and your test, then that will help inform your test plans, and then hopefully provide you some feedback on whether it was good or bad in the test. So again, sort of a broadly, here's where you're taking the MBCD concepts and now applying it to your test domain. So we're starting to build that with the extension here. So now we're finally starting to link it to your different domains here. And again, back a couple of slides ago, as they started to look at some of that strategic, operational, and system domains, now we're going to actually try to take that and then translate that into our test domain. So in our strategic domain, that's really the guidance. So that's really more of looking at the test domain, test guidance. What are you going to do for there? In our operational domain, now we're actually going to start to look more at the real world, the operational environment that you're actually going to do this, and hopefully your test environments will represent or closely resemble what you're trying to do in the real world before you actually build the system and deploy it. And then finally, the system itself, under test or under evaluation, and then you drive down into the specific details. So those are the three groupings that we're going to do as we extend our domain to the testing domain. Okay, so now we're going to start to explore a little bit more, and just instead of those couple of blocks here, and now we're going to show you, as we've started to build these different aspects within the MBCD construct. So we've got the test domain, which we already kind of explained about it. So that's really, here's the test environment, the test world, what you're looking at. You also start to build the operational domain. And again, this is going to represent a little bit more of the real world, trying to understand, what you're doing in terms of activities, nodes, interfaces, activities, metrics, how well do you do? What other constraints, what other needs are there? So again, trying to represent that, user sort of world to there. And then finally, with your system domain, now you're looking at the actual system that you're going to test, and then that's got its own bits of detail in terms of the components and the functions and the interfaces and the data and what it's going to do and how you're going to measure that, all linking together. So this would be good, except right now you're looking at sort of three different sort of stovepipe areas. So how do these actually relate to them? So now you start to use the MBCD approach, and now start to trace the different elements. So in this case, the test domain and the operational domain are going to start linking together in terms of your metrics, in terms of your plans, in terms of your test articles, test events, constraints, and so forth. So that's how we're going to try to link one to another. And also on the other side, now your testing domain is also going to link to your system domain. And again, with some of the metrics, the constraints, the functions, and then back and forth with your system to operational. So again, a very simple concept that we just described. And this, I think, is somewhat simplistic in itself, but to show you now some of the inner workings and the interdependencies. So if you change one block here, you're going to start to ripple through a lot of changes in all of the three domains. And that's really the point that we're going to that we're trying to push here with our concept here, is if you change one, hopefully you get some insight into what happens. So you don't just worry about your own specific area, but now I'm going to care about what you're going to provide if you make changes, now how's that going to affect me? And if I make changes, how's that going to affect you? So really, you're taking a holistic view to be able to understand the whole area. So you may not make some of those changes, not necessarily because that may have unintended consequences for the rest of the entire system. So that's where we're going. Okay, so the third segment now. So what we've done here, let me back up. So as we get this chart here, and then you can see where it's got just one directional, mostly it's unidirectional interfaces. So that's really the inputs as that goes as an output into a receiving element there. And we do this, carefully here, and you can look at it from a diagram, but how are you actually going to analyze this? So you can transform this picture here into a interdependency matrix, an n-squared matrix, either one that you call it. And really how you read this is that for this point, you can just look along the y-axis, what are you affecting, and then you read it across wherever there's ones, and then you go back up into the columns, and that's how you do that. So very easily you can start to show, and you can see it's not symmetric because it's not a bidirectional arrow. So it really depends on where I start and then where I'm headed. So an example here is if you've got a function, part in your system domain, and what does that affect? So for this example, it's 5 different outputs that function is going to provide. And then as you start to work your way up into the different columns there, that's where this function is actually affecting other elements within both the system domain as well as the operational and test domain. So that's just a very easy way to be able to show how one element will be interdependent with others. This is a simple example. Now try to make it real world and have like about 100-fold times. You can't really do that, I'll argue, just manually with a pen and paper. This one you can because it's small, but as you get that, now you can start to see the power of the model in doing some computer-based help there with some of the tool sets to then keep this all in line. And especially what happens when you change something, when you change an interface. How do you do that, and how do you make sure that it ripples through without trying to just do it manually for the 20th time? Okay, so that's kind of how we've started to build this, and so now we're going to try to evaluate how do these different linkages work. So when you have the rest of the model, what happens to the domain as we started talking about? So again, looking at that holistic view there and the different stakeholders that are going to be involved in this. So why do they care? So some decision makers, sort of the higher managements, that may be looking at some of the system development, maybe some of the test development. Here's the strategy overall. And again, when you start to make some decisions based on your test environments, you may add or subtract different resources or start to move your field dates. Well, that may be one area. Developers, again, as we talked about, that actually have to do some of the work. Well, that may change, depending on some of their different constraints or some of their different requirements. Well, then now they have to maybe change their efforts to be able to go through that. Analysts, as they start to work through that, you may have some other, changes in your environment, changes in your tests, changes in your test targets to be able to then, may affect your different system. And then finally, your testers, the actual people that you're going to be using, the actual system and testing it, that may actually have some changes. So again, the point is that it really depends on your different perspectives, and then not one person kind of rules them all, but you have to take that holistic view, and you have to take other people's perspectives in consideration as well. Otherwise, you may be making a sort of a terrible choice for someone else that you didn't realize. Okay, so again, that's all about insights and gains. What happens for that, and so finally, what happens to the once we've built this environments, and how do we make sure? So one, we want to make sure that that's somewhat faithful to our MBCD approach, and then finally, now we want to be able to to make some other changes in the different domains, and then to be able to make sure that we've got enough insight to when you make some changes, does that actually affect the other ones? So we'll say it's a first order and a second order effect. So we'll animate this in the next slide here and sort of talk about it. And really, as you're making your primary decisions, how's that going to affect your neighbor? But then how's that neighbor is going to affect the other neighbors, your neighbor's neighbors, to be able to use that. So we'll take a look at this. So really, it's the two charts. They should be the same with the X and Y axis. We're going to take our function that we did before, and we're going to change that. So again, if you're going to, just like we showed you with the example, to change the function in that system domain, how's that going to affect your different domains? This is the first order effect. Now we're going to take those effects, or those columns there. We're just going to put those same columns on the rows now in the first column. And then now we're gonna start to look at different domains and how does that affect all the other domains. So now that I've got the primary effect that had about 5 different effects, and now they in turn have about 7 or 8 or so secondary effects. So one choice, one change can actually affect a lot more. So that's really what we're trying to do. Yes, you can go, tertiary effects and all of that, but really trying to show, and that was a little challenging to be able to just describe this concept and to use the n squared matrix here in sort of a dynamic way to then be able to do that. And some tools can do this now with our MBSE tools to be able to try to show, how your different changes there. And that's good. Again, go back to the 2 slides ago about the different perspectives. How does the analyst look at this? How does the decision maker look at this? How does the tester look at this? And you may start to play what-if games of, is this good or bad for the whole system there? So now that we've got sort of our approach, our theory of how to be able to apply it to, now we're going to try to take an example. And Kevin and I, being from different countries, different areas, how do you take an example that's, not classified, not proprietary, something that is commonly used, and known and understand. So they actually did some work with the Department of Fire and Emergency Services of Western Australia. So that was good. They wrote some papers. So we used that just as a test, as a proof of concept, to be able to start to build this, context diagram. So, it's fairly similar from, and this is again 2017. So, when they didn't have as many fires as what was going on right now. And so again, it looks pretty similar to an incident, and then you have some sensors that can, hopefully interact with it. The incident alerting the dispatchers, assigning the nearest responder as they carry them to them with the responders, and actually can affect your incident there. So we can start to derive your different actors, your different systems, and the different functions that are going on there. So that was pretty easy to be able to look at that and use the approach there. So again, as we start to build some of our other test objectives, and how do you trace those to functions, and then how do you trace those to the actual elements, that was within the example there. So that was good. That was good to be able to just to say, hey, this is a good thing to be able to look at. And that's kind of where we stopped at 2019. So as we started to build our process and incorporating the test domain, considering the test community, and then something that hadn't been done in the literature, using the example, and then seeing does that actually make sense or not. And then finally sort of the next steps of can you use this, or actually the next steps here is, if you were to be able to take the next step and actually build this up in a model, and then try to collect data at significant milestones, data in terms of insight, in terms of understanding, in terms of completeness. If you were to do that, and obviously you'd have to have a project that you could easily incorporate the data and ask the different stakeholders. Hopefully then we can confirm that, by doing this at this approach, hopefully then you'd get better insight and hopefully make better decisions during the design phase. Okay, so that was 2019. So we're going to do a little preview here of what we're doing in 2020. And so this is our paper, again, that just got accepted Monday, they were told. So I think we hit about every key word here, hopefully. So when they do a bunch of searches, that'll pop up to be able to come to our presentation there in South Africa. All right, so what we want to do is we take the concept already, extend that to a initial problem, again, using that firefighting and emergency management, and then really looking at doing the analysis on this. So a little bit different, moving a little bit away from the model development and also using that to do some simulation and actually use the model to actually do some analysis to basically assess the testing, and really looking at sort of what do you use in terms of the test range and the resources, and how would you use this approach to be able to try to whittle down a more feasible solution set, as you'll see in the future here. So on the right, it's just a very crude sort of kind of game board, as you can start to see, of your test articles, so to speak, are your buildings. So again, if you set these up, and it depends on how many, where you set those up, how much is the density of that. Your extinguishers, so that would be our system under test. And again, that's the thing that we're going to evaluate, and then our fire elements, the things that are going to spread. So that's our sort of test targets there. So again, you'd like to be able to try to understand, how much am I going to put in there? How well is it going to do based on certain conditions? This is just sort of a random scattering of the different buildings and extinguisher locations and fire starting sort of locations. But now can we start to look at it from a test environment and a test setup? How well can we do a little bit more optimization and be a little bit more efficient in testing our area here? So again, we've got our test domain model that we're going to look at. So we're going to describe some of our dependencies, again, similar to what we had already talked about, and then transforming those. Really, that's the main part of the 2020 task, is to be able to take those elements and then build those into an analysis task there. So what we'll do is we'll start with our test domain that you already saw, and then now try to overlay some of our analysis elements that we're going to represent here. So again, back from 2019, here's our test domain. Here's what we're going to look at. And now for each one of these, we're going to start to be able to transform this into our analysis world here. So of our test range, and here's some of the metrics. Here's some of the capabilities that we're going to look at. Our run matrix is going to cover a lot of different types of test events. Our test targets, again, are some of those buildings. How many? What's the density? Our constraints, again, more of the fire elements. How many of these are we gonna put in? And also kind of what other environments are we gonna operate in? Because we have to, again, back to the operational domain, try to represent the real world. Our extinguishers, these are our systems under test, and where are they gonna go? And then finally with our plans, and also with our metrics as we're kind of doing that. So eventually you'd like to understand at the end, back to that game board, when you finished it, when the run has finished, how many fires are still, possibly burning out of control or under control? How many buildings do you still have standing, and how many are kind of burned to the ground? And that can hopefully show some sort of test metrics here. Okay, so for completeness here, how many do you need? How many? What are you going to actually look at? So what we've got here is three different types of test articles. These are really the density of buildings. We kind of call them rural, urban, and suburban. Our different physical environment types, if it's hot or cold, and that's really going to drive some of the performance. On our fire elements, again, how many are we going to put in? And our extinguisher types, a lot or a little. So if you look at the full factorial, the full complement of all the different permutations there, it gets 24, which is it's a fairly small number here, and this is kind of what it looks like in terms of here's your matrix. So you'd like to be able to you can just look at it and say, well, some of these are going to be grading really well for the extinguisher, some of them are going to be really bad just because some of the conditions, but somewhere in between. And the goal here is to be able to take these 24 as an example and really If I had unlimited money and unlimited time, great, we can do all of them. But typically that's not the case. So, how many are you really going to do? How many do you have? How much do you have budget? And really, you'd like to be able to figure out, what's my performance boundary, and then try to drive down to what's the best areas, so we can start to narrow down after a second cut, first cut, second cut, to be able to figure out here's the areas where we really want to focus and do some analysis. So the answer here would be in a couple of slides here on this is how we pick from this 24 to that dedicated number there. Okay, just a couple of rule sets as we do the game board sort of analysis. And again, it's sort of the first order here, but if you have, imagine that fire element, and then just logically, if it's adjacent to a building, that can also kind of catch on fire and kind of propagate throughout. Or if it's an extinguisher, then that extinguishes the fire, and then you kind of stop with that element there. And then also as you take your environmental performance, again, reading through some of the literature, if you have some of these other, higher temperatures, low humidity, higher winds, that will actually increase your fire spread. So again, you want to be able to represent, sort of the high and the low end of the environment, and then you continue on throughout the whole simulation until you stop it, or it can't spread anymore just because you have empty blocks here. Again, this is a first order approximation. There's plenty of folks that actually do this for real in terms of physics-based simulations and all that. That is not us. This is just trying to look at it conceptually and then hopefully give you some insight. Obviously, you want to make sure this is correct enough to be able to progress on to the next one. And again, from a test environment, yes, you definitely want to make this more realistic. But again, the whole point back to that 24 runs, if that's going to cost a lot, how well do you want to be able to shrink that matrix, still get the same performance understanding and insight, but not pay as much, and then make sure your testing is good. So this is just an example output from one of these what we did. So on the top here, you've got you've got the starting point, and the blue boxes are the houses. The blue dots are sort of open space. The red asterisk is your fire. The green is your extinguisher. And as you start, and just using the same rule sets as we talked about, as you can see, it starts to propagate until it hits an open space where it can't go anymore, or it gets extinguished by some of the fire extinguishers. So then you can start to analyze this to be able to then look at, how many more buildings do I have, at the beginning, and then at the end as it sort of plateaus, for when you finish the scenario. And then you can also start to count some other metrics as well in terms of your fires, number of fires, and hopefully those will start to die out, once you start to extinguish it, or how many buildings. And generally those are kind of inversely related there. So as we start to kind of run that, we start to run our 24 simulations, and we get some, and so we go through all of these just as we talked about. So the different density, the number of elements, the number of fire extinguishers, the weather, and really what I want you to focus on is some of the different chart dynamics and the chart pictures and shapes and graphs here. So again, so each of the yellow arrows. So again, the blue is sort of your intact buildings. So those are always going to kind of level off. Your red, your number of fires, and eventually they will start to hopefully die off. And your black is obviously your burned buildings. And so as we did all 24 runs, just looking at the different shapes, we have to do a little bit more work and understanding of why these different shapes, because we set the configuration the same. We do a little bit of stochastic work in terms of how it spreads and how well it spreads based on some of the weather effects and the fire elements or the fire extinguishers. But for the most part, it's a little bit more deterministic. So we need to understand the different shapes of the graph there, the results. So that's some work we'll have to look at prior to presenting in July. So we can also do some statistical analysis as well. We utilize a statistical tool, SAS JMP. So to be able to do all of the work in the 24 runs, and then you put that in the statistical tool really, and looking at the different factors, how much error, how many, how well does the linear regression model make, and how close is it represented. So really what we're really concerned of is that, if it's a high R squared, in this case, it's about 82% of the data that it represents, then you can have a little bit more confidence in terms of, making some predictions based on our regression model here. So just looking at this, and it can show you a couple of different items. And here are the different, for the arrows, here are the couple of the different factors, both single factors and cross factors that were statistically significant in changing the overall result, which is the number or percentage of unburned buildings that are still standing. And the R squared plot on the bottom. So really, as they draw the linear regression model, you got 82% of those points within that sort of that red cone. So again, that's good. 100%, 1.0, you're getting all the data and all the points and the errors. Start to go towards 0. That's not as good in terms of statistics there. Okay, so that's one way that we can use this. The other way, this is an interaction profiler, and can show in a little different fashion what different factors. Some are, just like we saw. Some are in independently, and then some are also, when they cross, then that means that some of the factors have some interaction between them. And as that makes kind of sense, weather and fire, as we already explained, some of the weather effects can help, spread the fire a lot more quicker. So again, this is another way to be able to look at some of the statistical ways to show this. Okay, so now that we get to the end here, so how do we use this? So you'd like to be able to then use this as an initial quick turn analysis to be able to show, how well, again, does that 24 runs, and how well can you start to narrow that down? So again, we did this really quickly. In 9 out of the 24, we're actually pretty good with better performance. This is just an Excel sort of coloring here, and I think it's about 40% or more that you had unburned buildings, then you were deemed a little better. You did well here, and as you can see now, it's the different runs there that actually had better performance. So that's another way to be able to start to look back into there, and we have to start to dig back into the details of why was that good, why was that not good in some of the other runs. But that kind of gives you a sense that you can now, if you were a program manager, decision maker. If that took 24 million to do all the runs, but now I can, make that into a third of it, then hey, I just saved 2/3 of my budget to be able to, and hopefully then to start narrow down into some of the specific performance in the better runs there. Okay, so that's what we did that's what we will do for 2020 in terms of trying to look at some of the artifacts, and then similar to what we did in 2019, and then convert those into some analysis elements, do a little bit of simulation, and then hopefully then apply that into potentially some of the resources as well. And so the next steps would obviously then to be able to take that this part, potentially if we had the ability to put some higher fidelity simulations, other types of simulations. I think agent-based models would probably be a very, very good one for this. But there's other ones as well in terms of doing some analysis and doing the process. And again, it's all about picking the right technique and tool set to be able to match that to the right problem to be able to then do some more work. Okay, so that's it. So those that are coming to Cape Town, South Africa, you'll actually see parts of this. And hopefully we'll see you there in July. Okay. Great.
Thank you, Dr. Flanigan. Is there any questions? Do we have any questions?
During requirements development, you'll often do verification requirements development and develop your verification criteria. So I'm just wondering how this tested evaluation planning that's done during the MBCD in that domain relates to the verification and test planning that you're doing during other stages in the process.
Yeah, great question. So the one chart that had sort of all the linkages back and forth, I think the primary thing we're looking at is how the test domain and the operational domain and how that links kind of back and forth. I think for some of the verification and how does that actually apply to some of my requirements and could I verify some of those? And then I think some of the validation, I think also looking at that operational domain and you looking at that as the user sort of space, and hopefully then they could also help validate that as well.
Thanks.
Okay, thanks.
Hi. So I think following up on that question, then it seemed like in your example, it seemed that the box that you were labeling test plans also included the performance results from the testing runs.
Yep.
I was wondering if you could elaborate on that a little bit. Thank you.
Yeah, great. Yeah, and actually we should probably go back to the, because that's probably a popular chart there. Yeah, so I think we had initially thought about test plans, and then also I think it's the other one. Almost there. Yeah, we were looking at, I think, the test plans initially as sort of like how you looked at, there we go, how you looked at what you were going to do and what you were going to build in there. And I think just trying to overload that in terms of you had some plans and then some thoughts were, could you actually kind of feed those back from some results to test plans? Yeah, I mean, could you probably put another block in terms of kind of test results or test repository or data repository? Yes, probably. That may be more appropriate. We were just trying to think of how could you minimize this at a higher level and then kind of feed that back in. But yeah, the thought was here's your plans, and then could you have some feedback on how well your plans did?
In all your techniques and so forth, it looks very much like an application of Taguchi design of experiments. And I saw the math at the end. What I didn't see is the matrices for the permutation selections. Did you do that kind of stuff to
Yes.
select the permutations?
Yes. So the full factorial actually was like a full factorial design of experiment approach. And then, and there are different techniques to be able to, if you do that or space filling or a partial, a fractional factorial, because they were so small, it was such a small number, then we figured we'd just do the full factorial for completeness for that.
I was just wondering how this approach would tie in with the use of use cases for coming up for the design of a system.
Oh, yeah, great question there. So I think using this just as a background to be able to try to then do some of your use cases. So the thought would be, as we had it, as we're kind of developing this, so then you take some of your different use cases for development system. And so in this case, we want to make sure that as you're building a system or taking a concept, from the beginning, that's generally what we see in sort of the operational domain. So you always get, inputs from the users, the warfighters, hey, my equipment's not good. Give me a better capability, get me a better system, your operational domain, your system domain. But sometimes we tend to think some of the testing is sort of forgotten. It's like, hey, great, we can build this great system here, but how are you going to test it? Where are you going to test it? doing a lot of our, one of the other classes I used to teach was system of systems engineering, where you have maybe like joint, programs or joint services. And now you're going to have like, a great joint system, but who owns the test range? And if it's multiple, is it the Air Force? Is it the Navy? Is it the Army? Especially when you're trying to build it, where do you test it? Is it one test range, or is it a bit of bunch of test ranges? And so that's where we really wanted to think about, don't leave the tester guys, sort of out in the cold. They need to be part of the conversation. So once you start to build some of these concepts, are the testing really should be involved at the beginning, rather than, as an afterthought, or yes, it's got to be testable for it, forward field. So that's where we were thinking about in terms of, use cases. And then you start to get into other use cases of, hey, what happens if I don't have the resources? Or what happens if I don't have, or different targets, or different systems? And how does that affect not only the system developers, but maybe also the testing environment of, hey, now I got a new system, or now I got a new threat. Well, now you got that'll represent the real world, but now you got to represent that in the test world enough so it can be believable. Otherwise, you've kind of wasted some time for that. So those are a couple of different use cases for the whole insight and the interdependency. So yeah, good question.
Dave, if I can just quickly, I love the idea of separating out the test domain. That the work that we do is primarily on the descriptive model side, and you could easily do that in a model-based systems engineering tool using almost any of the profiles and SysML. But the idea of in testing, you don't end up covering all of your use cases, and you need to do the analytics within the descriptive model to say, okay, I can't afford to test all 10,000 of my requirements. Which ones am I missing? And how does that go back up to the strategy level? And am I missing a key part, one of my stakeholder needs that determines success or failure? So I think this could easily be the descriptive model and the analytical M&S side of it. It's a great opportunity to move them closer together and help testers feel more valued.
Yes, absolutely. And so for those in the audience, this is Terry and Joe Wolfram. So they actually teach in the Hopkins Systems Engineering program as an introduction to model-based system engineering, and the follow-on is actually the analysis using the model-based system engineering by another one of our colleagues there. So I guess celebrity in the audience there.
In your system, in your simulation where you had some 24 different examples for the fire, were you able to establish a causality diagram for different variables and how one may have caused the other? And I wondered if that lend itself to any kind of sensitivity analysis, for instance, where you put these. Could you come up with a rule of thumb as to where you put extinguishers in certain cases?
Yeah, great question. To be honest, we kind of did this sort of randomly in terms of the placement here. I think but following some of the density sort of rules in terms of urban versus rural versus suburban and sort of the placement, and then also placement of the fires and the extinguishers. I think maybe potentially in retrospect, if we redid that in terms of more of a completeness, there'd obviously be a lot more runs, but systematically putting that in that grid and at every point, and then seeing where the most optimum location is. Yes, that would probably be I would say probably like a follow-on to this. So this was just more of a, hey, what are the main factors that were important? So I think it was number of extinguishers, number of fires, and weather conditions. I don't think that the density really made a difference. So I would go back and look at just those factors now and potentially those runs also to then do probably a little bit more exhaustive look at, now we're looking more at an optimization of where's the best place I can put an extinguisher that can save most of my buildings with the least amount of cost. So, yeah. Absolutely. Yep, sir.
Going back maybe to the second segment, or looking from the mission and conceptual design down the, left side of the V, in the development design and crossing over to the right side, DT&E, IoT&E, and doing the separate testing. Years ago, we found, like on the old Sprint Spartan system, you have synergistic effects, like the Spartan missile. You had to test certain shielding effectiveness, like Bell Labs did, under bending, at launch, which would degrade EM shielding effectiveness. So do you also, try to, in the requirements, look at the synergistic effects when you go to the right side of the V for test?
Oh, yeah. Yeah, absolutely. Yeah. So great question. Yes. So you'd like to be able to take into consideration the significant factors from your requirements, and then how do you represent those situations you just mentioned in the test environment to make sure then that your others, instead of ignoring it, and then you build a system that you may be inferior, and you don't want to do the test out in the real world and hope that it works, and it doesn't. So yeah, good point.
Take one last question.
Yeah, I was wondering how transferable your model is to other domains. I mean, you're dealing with fire and fire prevention, or mitigating actual fires. So let's say you had the spread of virus you have a virus breaks out in a country X,
Right.
and people are flying in airplanes to,
Mm-hmm.
that's one example. Another example, you have different centers of finance in an economy, and things can cascade.
Yes.
And, or you're just an Army commander and you want to know where to lay out fire bases because the enemy may come in any area.
Oh, yeah. Yep. Yeah. So great question. Yes. To all three of those are excellent examples. Different simulations, different tool sets to do that. Obviously the military ones here at the Applied Physics Lab that we work on a lot. I think we chose the fire just because that was a common one between Kevin and I, and it was easy to just look at the literature and use that. But yeah, absolutely. Any of those things that you said.
So are there any nuanced insight that you've gotten as a result of running these?
So we haven't run any other cases like you said, but yes, you could, for any of those cases, you would want to be able to look at if you set up the experiment right, if you set up the interactions and the modeling correctly, then you'd hopefully point out the.
Did you have any surprises as a result of running this model? Was something unusual that you didn't expect?
So when I showed the picture of the four, kind of the different patterns, that was not as expected. I was expecting, you're burned and you're unburned, so those will obviously, be sort of a mirror of it. But some of the fire, and again, this is how I kind of put it. So if it'll just kind of burn and there's nothing around it, it'll just kind of stay. Now, realistically, you could say after a certain point it could maybe die out or something. But that was an unusual point where, as we had just kind of built this just a little while ago before putting the paper out for submission, and that was something that we didn't expect. The different sort of shapes, and this is only 4 out of the 24. So yeah, that was an unusual point that we had. But yeah, that was a good point.
All right, thank you, Dr. Flanagan. I just want to also give you some tokens of our appreciation here. And the most gratifying one is the
All right.
coffee delivery
Awesome.
system, the
Great.
Cozy coffee delivery system. And
I
it's
know,
not a
it is.
mug, it's a system. And also a certificate of our appreciation and a coin.
All right, awesome.
All right, put that in your cup. There you go. Thank you.
All right, great.
All right, then we're going to auction off